Now let's go into a couple of quick definitions, and these are the only two words that are really going to be important. The two things that our lungs do, and consequently the two things that the ventilator does. We've got ventilation and we've got oxygenation. Now the two are not one and the same. Ventilation means the removal of carbon dioxide from the body. Our body produces carbon dioxide constantly. If we stop breathing for 10 seconds, our carbon dioxide goes up. If we stop exhaling, we're going to retain carbon dioxide. And carbon dioxide is very acidemic. Carbon dioxide is very acidic. It's going to drive our pH, which seems to be between 7.35 and 7.45. It's going to drive that down. And that's going to introduce a whole host of problems. And we're going to talk a little bit more about that later. The other function is oxygenation. Now when we take that breath, we're getting room air, which is roughly 21% oxygen. Good trivia question, and I know I promised none, is that at the summit of Mount Everest, the air concentration is still 21% oxygen, same as it is at sea level. Now the partial pressures are different, which is why it's very difficult to breathe at the summit of Mount Everest, but 21% oxygen is what we have all around us. Now our ventilators are capable of going up to 100% oxygen, meaning anywhere between 21 and 100. Now, we are going to talk more about how we oxygenate and how we ventilate our patients, but the important thing to realize is that we're not using the same mechanism to oxygenate as we are to ventilate. My favorite analogy for my students is that I have a flat tire, and at lunch I have to go out and change it. Does anyone have a salmon that I could use? I get a lot of dumbfounded looks with that, but the point is that you would no more use a salmon to change a flat tire than you would use ventilation to improve your oxygenation or oxygenation to improve your ventilation.